At the beginning, I would like to refer a bit to what Chris just said. So it's this fun fact is actually 100% true, though a bit sad. It happened in the way that we had a kind of setup on a desktop like that, and it fell down. So while I was trying to catch it, and obviously it was working and spinning, my thumb just passed through this net that you see on the screen. That's a metal net. It was not easy to do that, and stopped the propeller. So this hard way, I learned that it's possible to do that, but it's very painful. The fingernail regrows really slow, so it took almost a month to get it back in the right shape. And well, boss doesn't appreciate any stunts like that during presentations, so sorry, no financial refund. Okay, so I'm Piotr. I have over 13 years of LabVIEW experience, and at work I'm developing stuff for the real-time systems or FPGAs using LabVIEW. I also do some various and custom devices, a lot of scripting that is used for our tools that support our development. And quite recently, I have also learned to use Angular framework for the graphical user interfaces that really works great with LabVIEW. And today I'm going to talk about APIs in LabVIEW environment. So the abbreviation itself stands for the Application Programming Interface, which in simple words is a way that one application can communicate with another application in some predefined way. So strictly speaking, a server application, so the LabVIEW application needs to expose a set of methods, endpoints, typically developed as VIs, that later on can be called by some external, another application in the external world, and do some operations in it. The APIs can be handled locally on a single machine. So, for example, if you need to interact with some spreadsheets, you can open the Microsoft Excel API, load the file, perform some operations like reading the data, storing the data in it, do some formatting, and then just save it and release the reference. But they can also work over the network. So if you have a highly distributed weather monitoring system with a bunch of stations scattered among the city or country, and a local machine which is processing all this data, then the sensors need to expose a set of nodes or endpoints that this central processing unit can use to gather the data or push some parameters to the sensors. And now I know that's not a marketing event, but I need to say a few words about what we do to show that what I'm talking today about is not some theoretical stuff, but things that we learned through our experience. So at Tritem, we are providing hardware in the loop solutions. So they work in a way that customer has a unit under test that he gives to us. We wrap it with a hardware. So we have a specialized team of engineers that design and assemble test benches, like, for example, the one you see on the screen. Later on, we need to provide a working environment for this system. So we prepare simulations, testing frameworks, and so on. And that's the responsibility of the team I work in. And last but not least, we have a group of testers who are analyzing customer requirements for the system under test, preparing the test cases and executing them, after which they are reporting the results back to the customer. So back in 2009, we produced our first system like that. We had all the simulation models. We had designed the algorithm that would allow us to simulate the electrical circuit in real time. We had very fancy graphical user interfaces produced for that in LabVIEW, but we were missing the final thing. So the way in which our testers that were using testent back then for the test execution would be able to communicate with our simulation. And this is how our first API was born. At this time, it was based on VI server, which we knew, and that's the great benefit of that, it's the LabVIEW knowledge is the only thing you need to develop this kind of API. So we have built in a bunch of VIs that were compiled with our system, and then we were able to call them directly from testent using VI server and execute some actions in our system. Well, the great benefit of that is, as I mentioned, that you need only LabVIEW knowledge to achieve that. But on the other hand, it requires LabVIEW runtime engine, at least on each client machine that would call this kind of API. So when the customer came back and said that, well, we have a very fancy C#-based test execution system that we want to use together with testent, we got in a small problem because, well, it's not possible to call VI server directly from this tool. So luckily, LabVIEW supports that, and we were able to wrap it with a DLL, compile it for them. But, well, if this was any other language, we could get into trouble and not be able to fulfill their requirements. It has also low flexibility because, well, at least this approach that we took then. Because since our VIs were built into our system, each time it had to be updated or modified, we needed to recompile the whole system and also do the whole release process, so do the tests for it and so on. That takes time. And it is also not really portable, so it's not a multi-platform approach. So we were able to do that with testent, we were able to do that with C#, but there are a bunch of languages and environments that are simply not capable of calling VI server. So for the next approach, we wanted to be a bit more generic. So we based that on TCP communication and plain text commands that were parsed in our application. The example of that is on the screen. So that's also kind of benefit from this approach because user is able to open a terminal, connect to our system, and execute the commands in the same way as the application will do it afterwards when it is deployed. Another improvement in this approach is that each endpoint that was exposed in our system was a separate class. So we went for the plugin-based architecture, and we were able to update the API itself without touching the core of the system if it was necessary. So that gave us a really good flexibility and portability since well, TCP is supported everywhere, and also formatting a string command is not that hard in any language. The disadvantage of this approach is that there is a great amount of code that we need to produce in order to make it work. Because first of all, we had to implement the server that was listening for the incoming client connections. We had to implement the client handling services that were parsing the commands and getting the parameters out of them. So that's a huge amount of code to add to your application just to make the API work. And also, as the time passed, we wanted to make our solutions more modern. The customer requirements were different. So one customer wanted to have a map as in their graphical user interface. Another wanted to have a very dynamically configured user interface where you can add controls, remove them, arrange them on the screen, connect them to different signals in the system. So at this point, we decided to move towards the web technology. So that involve REST APIs, which I am going to talk about a bit more in the subsequent slides. WebSockets, if we want to have a very fast asynchronous communication. We also started to use standard formats for the payload. So instead of parsing the strings in our application, we decided to go for a JSON format, which is very easily parsable in LabVIEW. Well, you have built-in functions that allow you to get the data from the JSON string. The important thing here is that it has a built-in encryption. So if you have some kind of sensitive data that you need to transfer between systems, you just enable the encryption and your data is secured that way. And it's done under the hood by the web servers, and you don't have to do anything with it yourself. It has good flexibility because web services in LabVIEW can be compiled not necessarily together with your application. So if you need to introduce some change, you just compile the web services, put them back with your application, and you have new version ready to operate. And it has great portability because it works also directly in a web browser. So it's supported by multiple platforms, the scripting languages, and all the other stuff you may imagine. So let's talk a bit more about the web services themselves. So it's a request with response mechanism where client triggers a request by pushing some data or requesting a specific endpoint in the server. The server processes the data and afterwards responds with some kind of outcome of it. And that's it. Well, this is the end of the transaction. So there is nothing more. If something new is going to happen, again, this process has to be repeated. It is natively supported by LabVIEW. So you can very easily create both clients and servers of the HTTP directly in your LabVIEW project. So there is no need to have any third-party plugins or tools for that. This kind of API is exposed on a specific URL, so as in a web browser. So there is some base URL after which all the endpoints are placed. This kind of, there is an example here on the slide. So you have a localhost that is the IP at which the API is hosted, and the name of the web service, which in this case is my web service. They can be nested. So if you need to organize somehow your API, split it into parts, you have sensors, actuators, you can do that by simply putting another slash in the URL, and this way you organize the stuff on your API. And they can accept parameters. So if there is a need to pass some data to the method, you can just encode it in your URL just by placing the question mark at the end of the endpoint, and then separating with the ampersand sign, you place the key value pairs with your parameters. There is a bunch of methods available on HTTP, of which LabVIEW supports theoretically only 4. So that would be get, post, put, and delete. There is also possibility of use some others, but it's not really important at this point. And of those 4, we are using generally 2 of them. That would be get and post. They fulfill all the operations we need. So the get method is the one that you execute in the web browser each time you want to open some web page or web service. It is used to get a bunch of files from the server, so basically the HTML, some CSS styles, scripts, and so on, all the stuff that is needed to make your web page operational. It doesn't have any body though, so the only thing that it accepts when you want to push some data to the server is the URL encoded parameters that I was speaking about on the previous slide. But it has a great feature that it can be triggered directly from the web browser address bar. So you don't need any tool to be able to call your API. What do we use it for? So since it accepts limited or no parameters, we use it for operations like starting the system, stopping the system, loading simulation project, or retrieving some status data from our application. Here I have a small example of that. So that's a publicly available web service, which is used to get an information about the sunrise and sunset times or the length of the day. So in this example, it is called with a set of parameters, which are the position on the planet and also the date that is set as to be today. And in return, I get from the server information when the sun will rise, when there will be a sunset, how long is the day going to be today, and all the other stuff. So instead of getting web page, I have this JSON formatted string with this data together with some status in the end. And there is another one, it's a post method. The difference here is that it includes a request body. So we can not only pass data using the URL encoded parameters, but we can also push some string to our server that the server can process later on to fulfill the operation we request from him. But the difference is that it cannot be called directly from the web browser address bar. So you need, in this case, some third-party tool or another application that does that. But since we are talking about APIs, it's not really important to call it from the web browser. It's important that it can be called easily from another environment. It is good for executing methods which require a lot of data. So in our applications, we have to set some values of the signals. There is typically thousands of values in thousands of signals in the system we produce, or we need to read them back. So this example here shows that we are executing a set value command on the server of type force, which in the system like ours mean that we are not only setting the value, but also making sure that nothing else in the system will modify it until we unforce it. And together with this command, we are pushing the payload data, which includes the JSON formatted array of the signals, together with the values that they should be set to. The web service can be implemented in a bunch of ways in LabVIEW, but and I have a small demo on that, but I think I will push it to the end of the presentation if my battery allows me to show it to you. So maybe let's just say a few words about that. The LabVIEW has a built-in web server, and quite recently there is also an NI web server available together with that. Well, it's done a bit under the hood. So in the LabVIEW project, you may just right-click on a project top level and add the web service to your project, and well, basically that's it. So you may put there a set of VIs in it, and they are hosted on the URLs as seen before. But in case there is something wrong with this approach, or this is inefficient, we had a situation like that. It was a very big application, and well, for some reason, the embedded web services in LabVIEW took very slow to respond to the client's requests. So at this point, the easiest way out of it was to implement our own web server that, well, that was a small application, really. It was parsing the HTTP requests and handling what basically the web server would do for us. And this is how we made it to work faster. The last concept to speak about today are the WebSockets. And while I was doing research for this presentation, I came across a really perfect explanation for that, that I just couldn't stop myself of putting it here directly on a slide. So the WebSockets are, it's a technology that allows us to open a two-way interface communication between client and the server. Well, basically it works very similarly to our Teenager API. And so the text messages are transferred from the server to the client independently. There is no need to trigger any request by a client or pull the data from the server. So as soon as the new value arrives at the server or something like that, the server can send the message directly to the client. What you see here is what I already mentioned a couple of slides ago. So those are some of our graphical user interfaces implemented using this kind of approach. So on the top right, there is a map that we are using for the truck simulation environment for one of our customers. On the left, there is a dynamic panel. So each of the controls that you see there are dynamically configured. They can be arranged on the page. They are connected to different signals. They can be added, removed. So it's something that LabVIEW does not really provide out of the box for the user interfaces. And on the right-hand side, there is a electrical circuit. So as I mentioned before, a lot of our solutions involved electrical circuit simulation. And one of our customers wanted to have a visualization of that. So we went for the web-based approach. We loaded all the, I think, 600 pages of the electrical schema in our app. And there, I'm not sure, yeah, it's visible. So, and the state of the elements in the system, of the relays, of the wires is visualized on the web. It's also interactive, so it's not only visualization, but the client can also join some wires or force the state of the component. So even if the relay doesn't have a power supply, it can be switched to true, and we can observe the behavior of that. I have also some questions for you before we finish. So how many of you have some API in your application? Could you please raise your hands? Okay, I was expecting that. How many of you are using web APIs for that, REST APIs? Okay, any other solutions? Somebody like to share? What kind of? VI server, so our baby, well, that's fair. Anything else?
Custom TCP/IP.
So like with Teenager, right? Yeah, that works perfectly. It's really a good approach. Anything that was...
Basically, if you don't have tremendous load, if you don't expect multiple requests, they're not running Google.
Well,
no load balancing or anything like that.
well, yes, that's true. But in our case, we had both the automation test system and the user panels that were using the same technology. So we had to process multiple client requests. And well, this is why there was a need to actually produce this kind of handling, that we had a server.
You really need to load balance to have multiple handlers handle the same type of requests coming to the same endpoint.
Well, yes. Well, we had a priority for the test automation system. Well, there was no load balancing. It had a priority, but we need to handle multiple clients. So the services had to be run as asynchronous threads. And
that's a given. No, I was wondering if you had handlers, multiple handlers.
no, we had a single server that was doing all that stuff. And who is using the web services to provide the graphical user interfaces? Okay, I see one hand, or?
You mean the ESP scripting
Well, I mean the features like Angular or React or any sorts of stuff like that. So instead, yeah. Okay, so as a summary, I would like to say that it's worth to use standards. Well, they are provided out of the box. There is no need to implement some special stuff in your applications. It's also good to use standard file formats, well, text formats. So it's easier to parse JSON or XML in any application than do some custom string formatting and scanning. And well, the simplest solutions are the simplest. So if you have some very sophisticated application, it doesn't make sense to implement something that is already available straight away from the LabVIEW. So let me just quickly check if I have some more battery time to show you the small demonstration. Okay, I have something, so let's go for it. Okay, so I have it already opened. Is it visible? Okay. So what I mentioned before, in order to enable the web server in your application or create it, it's enough to right-click the, I think that's my computer, let's make sure. Yes, and select web service. In this way, you get this guy in the project where you can either place some files that would be normally hosted as a typical web server by adding a public content or private content. But what's the focus of this presentation is this part, so web resources. And this is the set of elements that are exposed in our application as a API. So here I have, for example, get status method that would get some information from the application. So the only thing I need to do is to provide some data from the application and connect the indicators to the control plane. And then once this method is called, the data will be formatted by LabVIEW and returned as a JSON or XML string. At this point, it's worth mentioning that the web services in LabVIEW are running in the same application instance as the main application. So you may use any technology like global variables or any sort of stuff like that to exchange the data between the application and the web service. So this is what I did here. So I have a global variable that provides the data for the web service. And I have also the same global variable used in the core application, which is not doing much except of setting the timestamp on this global or pushing the state of the system or providing the temperature readout. So it is a kind of reference to the example I was talking about in the beginning. So if I just start everything right now, I may go to the web browser window, get the URL of my get status method, and just paste it here. And in response, I'm getting the temperature and the timestamp that were exposed on this particular node. What I could also do, or let me just maybe modify the temperature to show that it's really updated in the web service. So here I have the new readout. What I can also do is I can provide some parameters for this method. So I could also ask the system to return this temperature for the last, for example, 7 days. And then when I execute this one, I see here in this in this handler for this node that the parameters were passed and scanned by LabVIEW without any need of my interaction. So this block is natively embedded in LabVIEW. It recovers the parameters from the URL. What I can also do, I can call another. I can have a client right now. So instead of writing this data in the browser, I can have a client calling HTTP methods in LabVIEW. Just make it more visible, perhaps. And here we see that I'm calling exactly the same URL that I was doing from the browser, using the HTTP GET primitive from LabVIEW, and then I'm parsing the return data using unflattened from JSON and pushing it to the indicator on the front panel. So if I right now start this one, I can see this temperature in the client following the one that is being pushed to the web server in the server application. So finally, I could call a method to close my application simply by passing the exit application link. And if you notice that the application was stopped. So that's one way we are using the web services. Another is to control the values in the system. So this is the example which I was talking about on the slides. So I have a set value endpoint. It's very similar to the other ones. So it parses the parameters, but in this case, it is also reading the post data from the request. So right now, if I start the client 2, which is a kind of emulation of our test automation system, it uses the post method to force the parameters, and here are the parameters that are going to be forced in the system. So if I run this one right now, I see that the method handler received both the request parameters formatted in the URL and the post data that was passed with the post method, which is a bit counterintuitive, I think, is that post method is not necessarily used with when you are pushing some data to the system. Because when we are getting the values from the system, we are also using the post method because it takes the payload data in which we may define what kind of parameters we want to actually get the values for. So instead of having the name and value pairs in a JSON object, we would have only the name, the array, the JSON formatted array of the names for which we want to get the values. So I think that's it for the demonstration. And as well for the presentation. So do you have some questions to what I just said or suggestions? Yes?
You've got a microphone, so if you could just hold off your question until you get a microphone.
So you didn't talk about that.
Well, yeah, I know. Well, okay. Well, that's true. Well, they are very similar to the TCP communication itself. As you would open the TCP communication between applications, it works in the very same way. The difference is that it is supported by the web browsers directly. So, Well, they also provide security as well as the web services themselves. So you may enable encryption, and that's also handled by a server.
That's the main event, right?
Yes.
Security and all that, you don't have to worry about.
Yes, yes.
It's very difficult for the rest of us to hear the conversation.
So the question was, what's another big benefit of the WebSockets? And well, the answer here is that they also provide security. So the same way that you may enable the encryption for the web services in LabVIEW, you may also enable encryption for the WebSockets. And then the data that is being transferred is secured. And you don't have to do anything with that. It's natively supported by the technology itself.
Hi. Quick question. So I do what you do in terms of your teenager API. I create black box software for production lines, and we use the TCP interface because it's very simple for other languages, like you say, like C#, Python, whatever they're using, even ladder logic, whatever, to create connections. From your experience, because I haven't pushed to do HTTP RESTful API-based style stuff, is it as easy for clients of, you know, your contractors to interface with it with their applications? Because TCP is typically 2 lines of code, regardless of the language.
Well, typically, languages have a kind of ready blocks that are handling that. So similarly as LabVIEW does, if you want to do the same thing from the web browser, there is a toolkit, let's call it toolkit, that you import, and you have the very same functions that you simply call. There is no need to wrap it with a bunch of lines of code. It's enough to load it, and then you have all the methods available for you. You may also provide the parameters, you may provide the payload data, add some other features that are specific for the REST API.
Thank you.
To complement on that, there's also... Yes, to add to that, when we are using a RESTful API or we are using the HTTP calls, then it all enables not only programmers for whom it is 2 extra lines of code, but also the higher level systems, which are like no-code systems to interact with machines, because they have just blocks, drag and drop, to make an HTTP call. So that enables the whole new area of connectivity, not only developers and programmers, but also those who are making the system integration.
Well, it's also worth mentioning that they are easy to test, because when you are developing an API like that, you may use either a web browser to trigger the command, or in case of post method, you could use a postman to execute the command, pass the data, and check manually if it works.
Hello. As I understood, you told that you replaced the NI web servers by another implementation?
Well, that was a very specific case. Actually, it's a bit related to the first application I mentioned, so the one that was using the baby API. So at some point, we wanted to introduce the web services to it. And, well, actually, it was quite easy because we had a good architecture there. But the system is huge, and it's compiled to a single executable. And for some, to be honest, unknown reason for me, the web services took a very long time to respond. So even if we had some empty method that was not doing anything, the embedded web server took a bunch of, well, I think it was up to 100 milliseconds just to parse the command and send empty response. Well, we didn't manage to explain it. The easiest solution we found, well, obviously we contacted NI for that, but you know, NI quite often needs your code to analyze it. That's a reasonable approach, which we simply couldn't give to them because that was proprietary knowledge of our customer. So we did parse the commands manually. There was only a bunch of those with very limited number of parameters, so it was not that hard.
That would be my next question if you investigated what happened, but you just answered. Yeah.
Well, HTTP request is simply a string sent over TCP to your server, so we parsed it in the very similar way as we did for the teenager API. Okay, any other Questions?
Hi. Have you experienced GraphQL with LabVIEW and LabVIEW web server?
Sorry?
GraphQL is to replace REST API. Instead of having many endpoints, you just have one, and then after the response is different depending on the request. Just
Okay.
to know, it's a little bit
So would
aside the subject. But
So you said that you are using, instead of having multiple endpoints, to have a single endpoint and then
yeah,
pass a parameter to that would...
and depending on the request, the answer body will be different. It's a
okay.
technology, but just wanted to know.
Well,
maybe
we
can-
didn't try that. Well, it seems also not very straightforward to me. I prefer to have a different endpoints that are doing their specific job, and then I have a simple VI that is doing that, instead of passing the, like, having one endpoint and then passing the command as a parameter.
Okay, just wanted to know.
But in order to decouple our applications from the web service, we quite often have a kind of internal data exchange mechanism that could a bit resemble to what you just mentioned. So there are often situations when the web service cannot do directly all the stuff. Then we need to pass the command to our system, and then after the system finishes the execution, it passes back the response to the web service, and it is sent back to the client. So this way, it could be implemented. We could implement what you are suggesting, that we could have a command as a parameter of a single endpoint.
Thanks.
So this all comes to basically two fundamental ways of communicating between two modules wherever they are, asynchronous and synchronous, right?
Yes.
So in the case, in reality, of course, you have multiple modules talking to each other in finite time mode, right? It takes finite time to process any request, right? Moreover, the response, the reaction of a particular module to a particular call or a message, whatever that is, right, will depend on its state. And that state can be very complicated. And sometimes it may not be, right? So did you consider, like, and we are talking particular ways here of basically messaging or doing a remote procedure call. Nothing more than that. This is all about message, send a message asynchronously, and receive it asynchronously without particular, without blocking, or asynchronous remote RPC call. So did you think about kind of generalizing this, pushing down the particular method of whether it's a socket or whatever down, and having kind of higher level API which would be able to provide any kind of information exchange kind of between two particular modules, whether they sit on the same CPU in different processes or on different machines or whatever. To make kind of the ultimate API in a sense, well, at least higher level than this. Say separately maybe for synchronous and asynchronous, of course, but asynchronous is preferable.
Okay, well, I'm not sure if I get the question right, so maybe let me say a few words about this example on the left, and you will comment if this is what you pointed to or not. So for this particular one, this is used for a system consisting of, let's say, 3 subsystems. So we have Veristand, we have 2 instances of our electrical simulation that has its own API. In that case, the Veristand was also wrapped with the handler that allows us to communicate over the network. But since we didn't want to implement everything in a browser, we created a single application that was wrapping all those distributed clients. And then for the application, we had a single communication method.